Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. How are you? I hope you'd be fine. I'm here with a new chapter of your book D3. This is chapter number 4, Indices and Standard Form, and we are going to deal with exercise 4.1. On page number 84, you'll find this exercise 4a. Here we have 3 levels: basic, intermediate, and advanced level. We are going to learn the laws of indices while solving these questions. So pick up your pencil and let's begin the solutions from question number 1. We have 4 parts in question number 1, which says simplify each of the following, leaving your answer in index notation where appropriate. So let me tell you first what is index notation. As you can see over here, I have a number 2 and a power 3 over it. So this number is basically called base, and this power is called its index, right? And the relation between these two is called index notation. Okay, students? This is index, the power of 2, and this relationship between the base and index is called as index notation. Okay, this is question number 1, part A, which says 2 raised to power 3 into 2 raised to power 7. How we need to deal with such questions is basically we have to apply a law of indices number 1. Okay? Law number 1 of indices, which says that when we have 2 variables or 2 bases which are similar to each other, and they have different powers or similar powers, all we need to do is we need to add up their powers, their indices, right? As you can see over here, we have 2 numbers, that is 2. 2 here and again 2 here. These 2 are similar and they have powers as 3 and 7 respectively. So all we need to do is we are going to add up their powers and not their bases, right? Why are we doing this? Because law of indices says that if A is a real number and M and N are positive integers, then law number 1 of indices says that A raised to power M will be added to N. Understand? So remember, it's very easy. Whenever the bases are same and they are multiplied to each other, all you need to do is to add up their powers. Bases are multiplying. We do not need to do anything to them. Instead, we have to add up their powers. So the answer would be 2 raised to power 10. Right? This is the answer. And why are we doing this? Let me explain you. 2 raised to power 3 to 2 raised to power 7. It means 2 is multiplied to itself 3 times, right? And then here 2 raised to power 7 says that 2 is multiplied to itself 7 times. 2 multiplied by 2, multiplied by 2, multiplied by 2, 3 2's and 1 more. So in total, how many 2's do we have? We have 10 2's. 3 of this one and 7 of the other 2. So these are in total as 10 2's. They are getting multiplied to each other. So we can write their power as 2 raised to power 10. Simple. Which is the answer that we got from this formula number 1. Now part B says we have bases minus 4 and the powers are 6 and 5 respectively. So all we need to do is we'll keep this base as it is and we'll add up their powers, that is 6 and 5. So we'll get the answer as minus 4 raised to power 11. And students, remember, whenever we have a base negative and it has an index that is even, the base will turn into a positive integer. But if the power or the index is odd, this negative base will remain negative. How? Let me prove it to you. For example, I have a minus 4 over here and power as 2. That is even. When I'll multiply minus 4 toys, that is to itself once, I'll get 4 into 4 as 16, and minus minus will be turned to positive. So this minus 4 will be plus 16. In contrast to it, if I have an odd power, so I'll expand it 3 times, right? Minus 4 into minus 4 into minus 4. 4 into 4, 16. 16 into 4 is 64. And this minus minus plus, plus minus minus. So the answer is again negative. So whenever we have a power that is odd and we have a base which is negative, so it will remain negative. Understand? But if we have a base negative but a power with even number, it will turn to a positive integer. Remember this thing. Now part C says x raised to power 8 into x raised to power 3. So the answer would be x raised to power 8 plus 3, that is 11. This is the answer. Now a bit tricky question. Here we have 3y squared into 8y 7. So all we need to do is we will find out the same basis. Here we have same basis as y, but their constants are different, that is 3 and 8. So what we're going to do is we will multiply 3 with 8, which is 24, right? And now we'll add up the powers of y which have the same base, that is y. So y square multiplied by y 7 will gives us y raised to power 2 plus 7. See? So simple. I told you earlier that when we have bases as a variable and coefficient, so we have to multiply the coefficients separately from the variables, right? We have to deal coefficients and variables separately. So we are going to multiply these coefficients separately, and then we are going to add up the powers of y, which are 2 and 7. So we'll get the answer as 24y 9. This is the answer. So you see, students, it's very simple. All you need to pay attention. Now we have question number 2, and now we have to learn law number 2, which says that when same bases are divided to each other, all we need to do is to subtract their powers. How? It's a raised to power m divided by a raised to power n. Will simply subtract the powers. Why? Because we know that division is the reciprocal of multiplication. So if we add up the powers in multiplication of same bases, we will subtract the powers when it comes to division of same bases. Here you can see we have a as bases, so all we need to do is we have to subtract m from n, right? So what we are going to do here is m raised to power m minus n. Let's apply this over here. 5 as base, right? So we'll subtract 5 from 8. We'll get the answer as 5 raised to power 3. This is the answer. Part B says minus 7 raised to power 11 divided by minus 7 raised to power 4. We have bases as minus 7. We'll write it over here as it is. And then we'll subtract 11 and 4. We'll get the answer as 7. Minus raised to power 7. This is the answer. Now part C. Here we have bases x similar to each other, but the coefficients are different. Here we have 6 as coefficient, but here 1. So 6 divided by 1 gives us 6. 6 will remain same, right? And all we need to do is with x, we are going to subtract the powers. So x raised to power 7 minus 3. The answer would be 6x raised to power 4. This is the answer. And then part D, minus 15 y raised to power 9 divided by 5 y4. So we are going to deal the coefficient separately from the variables. Minus 15 upon 5. We will deal it separately from y, and y raised to power 9 minus 4. Because here we have same basis, so we'll subtract 9 with 4. 5 ones are 5, 5 threes are 15. The answer would be minus 3y raised to power 5. This is the answer. Okay, students, I hope you get it. Now question number 3, part A says 9 raised to power 2, bracket close, and we have another power 4. So we have two powers on a base, one inside the bracket and the other outside the bracket. When we have such a question, we have to follow law number 3 of indices, which says that when we have a number, a base, such as a power inside the bracket and a power outside the bracket, what we need to do is we have to multiply these two powers to each other, and then whatever the answer we get, we are going to apply this on the given base, right? This is law number 3, so you have to remember this law in order to solve these type of questions. So we are going to simply multiply 2 with 4, which is 8. The answer would be 9 raised to power 8, right, for the given question. Now part B says h raised to power 2, bracket close, power 5. So we are going to multiply this 2 with 5 and we'll get power 10. This is the answer. Okay, now we have a sort of a different question. So first we'll try to deal it in the same way we have learned so far. Here we have two powers again, one inside the bracket, the other outside the bracket. So we are going to multiply these two and we'll get the power as 14. Now students, we have 3 raised to power 14 into 5 raised to power 14. The bases are different, but the powers are same. So for such questions, we need to deal in law number 4 of indices. So my dear students, law number 4 says when you have two different bases with the same powers, with the same indices, all you need to do is you need to multiply the bases to each other, keeping the base as it is, right? This base will be as it is and the bases will be multiplied to each other, right? This is law number 4. This is altogether different from law number 1, where we had same bases but different indices. What we did there? We simply added the indices. But here we have different bases with same indices. So what we are doing, we are multiplying the bases with each other, keeping the index same. Now come back to part C. 3 raised to power 14 into 5 raised to power 14. What we are going to do is we are going to multiply the bases and we'll get 3 into 5 as 15 raised to power 14. Right? This is the answer. Same goes with part D. Here we have different bases with the same powers. So we are going to multiply 2 with 9 and power will remain same as 3. 2 9s are 18. So the answer is 18 raised to power 3. Now students, part E says 2k raised to power 6 and the whole has the power 3. So this power that is outside the bracket applies to both coefficient and this variable. But the power inside this 6 is only with this variable k and not with the coefficient. So we have to apply law number 3 with the variable that is k raised to power 6 and the variable with outside power as 3. So we are going to deal with this coefficient as 2 raised to power 3 because this power goes both with the coefficient and the variable, right? But when comes this variable, it has an inside power that is 6 and an outside power that is 3. So we are going to apply law number 3 and multiply these two powers. So we'll get 18. 6 3s are 18. So the answer would be 2 raised to power 3, which is 8k18, right? Why we are writing the answer in number and not in powers? Because it is very small. Otherwise, we would have kept it as it is. Similarly, we have part F, which says minus 3x6y squared and the whole as power 4. So this power applies to both the coefficient and the two variables, right? How we are going to do this? Minus 3 raised to power 4, then x raised to power 6 into 4 is 24, then y raised to power 2 into 4 is 8. Right, students? And then here we have a negative base, and I told you earlier, if it has an even index, then this base will turn to a positive integer. Minus 3 raised to power 4 is 81. And because of this even index, this base will turn to a positive integer. So we are not going to write here minus 81, but 81, right? 81, x raised to power 24, y raised to power 8. This is the answer. Okay, now dear students, this is question number 4. Part A says 14 raised to power 13 divided by 7 raised to power 13. Again, we have different bases with same powers, but the operation in between them is division and not multiplication. For multiplication, we had law number 4, and now for division, when we have different bases with same powers, we have law number 5, which says that if a raised to power n is divided to b raised to power n, all we need to do is to divide a with b, keeping the power as n, only if b is not 0. So we'll apply the law number 5, which says that divide 14 with 7, keeping the power as 13. So 7 ones are 7, 7 twos are 14. The answer would be 2 raised to power 13. Right, students? Okay, now part B, 9 raised to power 5 and a power outside is 4, and then divided to 3 raised to power 20. So here we have to apply both laws, law number 3 and law number 5. Law number 3 says when you have two powers inside and outside, multiply them. So we are going to multiply 5 with 4, which gives us 20. And then we have 3 raised to power 20. So we have same basis, same index now. So what we are going to do is we'll divide 9 with 3, keeping the index same, that is 20. So 3 ones are 3, 3 threes are 9. The answer would be 3 raised to power 20. This is the answer. You see, students, all you need to do is to learn the laws. Because if you learn the laws thoroughly, you just have to apply them, right? Wherever needed. Here we have a question, m upon 2 raised to power 5. So this m goes with 5 and this 2 also goes with 5. The answer would be m raised to power 5 upon 2 raised to power 5, that is 32. Right? This is the answer. Similarly, part D says 3 upon n square whole power 3. So this 3 raised to power 3 and n raised to power 2 into 3 is 6. So 3 raised to power 3 is 27 upon n6. This is the answer, students. Similarly, question number E, that is P4 upon Q raised to power 6 as a whole. So P4 into 6 is 24 and Q as 6. This is the answer. Right, students? So simple, so easy. Just need to focus. And last of all, of this basic level, we have a question minus x upon y square as power 4. So when we multiply this, I already told you that when we have an even power, so the base turns into a positive integer. So this even power will turn this negative integer into a positive integer. X raised to power 4 and then y raised to power 8. Right? This is the answer. I hope, students, it's very much clear to you. Still, if you have any sort of questions, any sort of queries, any sort of problems, you can ask me in the comment section. Please like the video. Thanks for watching the video. Subscribe to my channel if you are new. Don't forget to press the bell icon. Take care until the next video. Allah Hafiz.